right, hi friends. We're going to introduce variables to our square roots. If you're not comfortable with evaluating a square root with numbers, please refer back to the previous videos before continuing on with this one. I'm going to assume that you're comfortable evaluating a square root with numbers at this point. All right, so a really important thing that we need to know is what is the square root of x squared? This is really important, it turns out. So I want you to think about the square root and squaring a number as opposites of one another. Let me write that up. So square root and squaring something. So like squaring. They're opposites, kind of like multiplication and division are opposites of one another. So when we have the square root of x squared, they undo each other and it's just going to be equal to x. That's a really important thing that we need to know to evaluate square roots of variables. Now this relates back to exponents in a really important way. And one thing that we just need to know is that the square root of x is equal to or can be rewritten as x to the 1/2 power. Now I'm going to put some numbers in there, and these are sneaky numbers that we don't always write. If I have x, it's also x to the 1st power. And if I have a square root, remember I have an implied 2 out here on this. I bet you can see why I did that, because this 1/2 comes from the exponent on the x and the square root symbol. All right, so this is very important, and I want to show you how it relates back to the square root of x squared being x. So if I have the square root of x squared, that means that I can rewrite this as x squared to the 1/2 power to indicate the square root of x squared. And let's put some color to that just to make it a little bit more clear. I'm going to color in that square root symbol orange. And then I'm going to do the parentheses and the 1/2 power in orange to indicate that those are the same thing. Now remember, if we have a power to a power, so x squared to the 1/2 power, this would be x squared, or x to the 2 times 1/2 power, which is just x to the 1st power, or x. All right. This is important as we roll through some examples of finding square roots involving variables. Let me put those up on the board. Okay, let's take a look. So I have the square root of 49x squared. Remember that we can break this up. I can break it up as square root of 49 times the square root of x squared. And that's really important because it allows me to deal with the numbers separately from the variables. 49, as you recall, is one of our perfect squares. So 49 is equal to 7 times 7. So the square root of 49 is just 7. And remember, we just talked about the square root of x squared is just x. So in place of square root of x squared, I'm going to write x, and my final answer would be 7x. Let's take a look at the next one. The square root of 72x squared. I'm going to break this one up as well. So I'll write it as square root of 72 times the square root of x squared. Well, square root of 72. 72 is not a perfect square, unfortunately. So we're going to have to break that one up. But hopefully you notice that 72 is equal to Well, one option is 9 times 8. That's probably the first one I would go to. Another thing I could break it up as would be square root of 36 times the square root of 2. And I want to tell you that both of those will work out exactly the same. So let's work the first one. If I did 72 is 9 times 8, we know the square root of 9 is equal to 3. We know that the square root of x squared is x. So I would have 3 times square root of 8 times x. Uh-oh. Square root of 8, that has a perfect square factor of 4. So let's break this up one more time. So I'm going to rewrite that as 3 times square root of 4 times square root of 2 times x. All right, square root of 4 is just 2. So we would have 3 times 2 times square root of 2 times x. Kind of looks like a mess. But we know 3 times 2 is 6. So this would be 6 square root of 2 times x, but I want to tell you, we have a convention that says we rewrite this slightly differently. We put the x in between the number and the square root. Now the reason for this, I believe, was when they used to use typesetting in order to do textbooks, and it was hard to tell if the x was underneath that square root or not. So they would move the x to in between the 6 and the square root of 2. We're not necessarily doing typesetting anymore, but the convention still stands, and we would write this as 6x square root of 2. Now, that's probably the main way people would notice this, but what if we said, oh goodness, I know that 72 is square root of 36 times 2? Might have been a little bit simpler. So square root of 36 is just 6. Square root of 2 stays the same, and the square root of x squared is just x, which then we would rewrite as 6x square root of 2. No matter which way you went, you would get the same answer, and it would be okay either way. All right. Let's go up to the top. We've got square root of 125x to the 4th power. All right, the first thing I'm going to do to break this up is square root of 125 times the square root of x to the 4th. We want to think about, does 125 have any perfect square factors? It does. I can rewrite that as square root of 25 times the square root of 5 times the square root of x to the 4th. I'm going to do that a little bit differently. I'm going to write it as x to the 4th raised to the 1/2 power. And I'll show you why. This reminds me that when I evaluate the square root of x to the 4th, this is going to be x to the 4 times 1/2 power, which would be x squared. All right, let's go backwards. Square root of 25 is just 5. Square root of 5 I can't do anything with, so I'll write it down. So I would have 5 square root of 5 x squared, which is a perfectly good answer. However, convention tells us to write it as 5x squared square root of 5. But these mean exactly the same thing. We just tend to write that x squared on the front of the square root. All right, next example, square root of 200x cubed. Couple of things I'm going to do here. I'm going to break up 200 into a perfect square and another factor. I'm also going to break up this x cubed into a perfect square and something else. Let me show you what I mean. So my first break is, of course, square root of 200 times square root of x cubed. We've been doing that so far. Let's think about square root of 200. This would be the square root of 100 times 2. So I'll write that as square root of 100 times the square root of 2. And then we're multiplying it by the square root of x cubed. Well, x cubed isn't a perfect square. So I'm going to rewrite that as the square root of x squared times the square root of x. Now, square root of x squared times the square root of x, that's just going to be the square root of x cubed, which is what we had right here. But the cool part is we have some things we can evaluate. So, in place of square root of 100, I'm going to write 10. In place of square root of x squared, I'm going to write x. And then let's write down what we have left. So I still have that square root of 2 and that square root of x. All right, I want to remind you of an important rule we learned a couple videos back. It was if I have square root of a times b, it's equal to the square root of a times the square root of b. And we used it to go from this left side to the right side. Now we're going to use it backwards. So instead of going from square root of a product to two separate square roots, we're going to go from two separate square roots to combining them underneath a single square root. Let me show you how this applies. When I have square root of 2 times square root of x, I'm going to rewrite that as square root of 2 times x. And then we will multiply the 10 and the x, and they just go on the front. So we start with square root of 200x cubed. We break it up into numbers and variables. We break each of those into their perfect squares, and then we combine them back up after we simplify to end up with 10x square root of 2x. All right, let's try another one similar to that. So, square root of 24x to the 5th power. This would, of course, be square root of 24 times square root of x to the 5th power. I'm going to approach this very much the same way as our previous problem. 24 I'll rewrite as square root of 4 times square root of 6. X to the 5th, I want to write it as a perfect square times whatever's left over. Remember that x to the 4th is a perfect square. It's x squared squared. So this would be x to the 4th, square root of x to the 4th times the square root of x to the 1st, if we were to write that sneaky 1 up there. So let's see what we can evaluate. Square root of 4 will just be 2. Square root of x to the 4th, just like above, is going to be x squared. And then we'll pull down the pieces that cannot be simplified. That's square root of 6 and square root of x. So at this point, I have 2 square root of 6, x squared, times the square root of x. We're going to rearrange those. So I would have 2x squared times the square root of 6 times the square root of x. And remember that we can combine square root of 6 and square root of x to have 2x squared square root of 6x. So On these problems, it's important to just take it one step at a time, write down each step, and be extra careful as you go through so that you can follow your work and get the right answer.